Hi, Brother Nelson. This is Ryan Nielsen with my final project. I'm going to try and get through quickly because I know you have a ton of these, but there are a few things I want to explain. First off, I didn't get on to phase 2. As you can see, my subtract isn't connected to anything. But considering I came into this class not even knowing how to count in binary, I'm really proud of myself for everything that I've done. But anyway, moving on. So here's my clock. Here's my clear. My clear I also connected to the ASCII display just so I can toggle the clear on that. And I'm sure this stuff is exactly what you're going to be seeing with 30 other students. But just to show that I haven't used any libraries, my decoder is just made up of AND gates. My 8-bit register, well, my 8 4-bit registers are made up of 8 4-bit registers. There you go. And then we just got the muxes, port A and port B. And then if we look at the ALU, we'll see XOR and or add. And again, all of these are nothing's coming from the library. I created all of these. So the and, oops. And the and. There we go. Okay. The one thing I wanted to explain, though, was the way I wanted to do this, just to kind of test myself, was because the ASCII display uses hexadecimal, adding two numbers together wouldn't display it exactly. So I noticed a pattern on hexadecimal is that our digits, our numbers 0 through 9, begin with 3, whereas if we start with the 2's, we get symbols. So I decided, if you look at the code, with the code I have right here, I load into register 7 a 2. And then I use that 2 when I'm displaying. So if we compare 3 plus 4 equals 7, you'll see that I add here and then display. And that is, I am displaying the 2 plus the 7, and 2, 7 is going to be an apostrophe. Then 3 times 3 would give us 9, and a 2 with the 9 is going to be a closed parentheses. So that's the way I decided to code it. That way I know that my arithmetic is correct, as opposed to just simply hard coding it all. But anyway, a quick demonstration. This is what it looks like. So we get ticks enabled. We'll get hello, Brother Nelson. Then 3 plus 4 equals 7. Now the actual arithmetic, apostrophe. 3 times 3 is equal to 9. Actual arithmetic. And then I did this one even though I don't have the sub in. But yeah, it's all there. Like I said, I wasn't able to get on to phase 2. But considering what I started with, literally not knowing how to count in binary, and now understanding ROM and understanding more about computer language and exactly how memory is stored on the computer, how we can affect that, I'm amazed at everything I've learned in this class. This class has been a blast. I'm already going way over the limit. I apologize. So I'm going to end here. But here's my presentation, Brother Nelson, and thank you for such a wonderful class. This has probably been the best class that I've taken at BYU. Maybe my anatomy class at BYU Provo, because that one had a cadaver lab, and that was amazing going through that stuff. But anyway, I'm going to close here. Thank you again for such a wonderful semester, and have a Merry Christmas.